I wanted to walk through graphing a system of equations and then testing your answer, see if it works. I'm going to go with number 23 here. This one's an interesting one. Now, we can't really graph it as it is because we have two equations here. Right now they're in standard form. In order to graph them, I'm going to need to put them in slope-intercept form, which means I need to isolate my y. So I'm going to do x plus y equals 9. In order to get the y alone, I'm going to subtract x on each side. That leaves me with y equals negative x plus 9. Now, in order to graph that, I've got my y-intercept of 9. And now, I don't have a value here for my slope, but I can always put in 1. Because identity property tells me anything times 1 will always give me itself. I can always plug in that 1. So, I have a slope of negative 1. So, I can graph this now. I'm going to start with my y-intercept of positive 9. Go down 1 over 1. Then over 1, just like so. Make a little triangle. Do it again. It's always good to at least get 3 points. I always recommend that. And I got myself a nice line here. At least I should. It's not always easy to get that line drawn, but I think I did a pretty good job of it. Alright. Pretty good. Alright. So now I have the second equation I have to worry about. So now I have x minus y equals negative 7. There are a couple ways I can go about this. That's just my dog shaking. Now, I have a couple ways I can do this. I can try and get the y over here. I can do some moving here, but I think what I'm going to do is I'm just going to subtract x. I'm going to do that. Leaves me with negative y equals negative x minus 7. Now, a lot of people would be content to just say, okay, I'm done. Y is alone, but it isn't. As we established before, let's put a 1 there. So now I have negative 1y. In order to get that alone, I got to divide negative 1 on each side. By doing that, I get a positive y here. Negative x divided by negative 1 gives me positive x. Negative 7 divided by negative 1 gives me positive 7. So now I have a slope of positive 7. Well, I mean, not a slope, excuse me, a y-intercept. So I'm going to go 1, 2, 3, 4, 5, 6, 7, right here. And now I'm going to go up 1, over 1, and I'm already finding the solution to my system. They're crossing right there. So I'm going to carry it on, not a perfect line. But I did get my solution here. If I zoom in, the coordinates of this point are 1, and then 1, 2, 3, 4, 5, 6, 7, 8. So I've solved my system by graphing it. Now the thing is, what a system ultimately tells you is it gives you an x value and a y value that will work for two equations. So this should work for both of these. To make sure it works, I'm going to plug them in. I'm going to start with x plus y here. Equals 9. Now I just plug in these values. For x, I have 1. For y, I have 8. 1 plus 8 equals 9. Checks out. I'm going to try it for my second one here. Just x minus y is supposed to give me negative 7. Let's see if it works. So if I do 1 minus 8 equals negative 7, what do you know? Checks out. So that's how you solve this system, by graphing. What I did was I had two equations that were in standard form, got them in the slope-intercept form by isolating y, graphed it, and then I found where my two lines intersected. That ordered pair gave me an x and a y value. Then I used those x and y values and plugged them into each of these equations to make sure that these solutions worked. And they did. So that's how you solve a system of equations using graphing and then checking that ordered pair by plugging it in to your equations. Hope this helps.